Good morning, children. Until now, we have discussed the definition of motion, distance, displacement, speed, velocity, average velocity, uniform and non-uniform motion, acceleration and retardation. Today, we will see how motion can be represented graphically. Now, what are graphs? Graphs are very powerful and convenient method of representing information or data. You must be familiar with bar graphs and line graphs in mathematics. Now, if you see here the table, it gives the scores at the end of each over in a cricket match. And at the left side, you can see the representation of these data using graphs. You can see here it is a bar graph, and if you see just above these bar, you can also see a line. So it represents data using bar graph as well as a line graph. Generally, a graph displays the relation between any two quantities. If you see this example, that quantities are scores and overs in a cricket match. And one of these quantities is termed as independent variable and the other quantity is termed as dependent variable. Here the independent variable is overs. So as the match progresses, we know that the overs keeps on progressing. And during each overs, the scores may be different. So here over is an independent variable and score will represent a dependent variable. How do you draw and plot a graph? If you can see the graph here, you will see that there are two lines. There is a point of origin which we usually represent by the letter O. If you see the vertical line, that is termed as the y-axis, and the horizontal line is the x-axis. So the independent variable here it is overs, it is always represented in the x-axis, and the dependent variable is represented in the y-axis. Then another important component when you draw a graph is to choose a scale. So you have to choose it very carefully, studying the range of data given. You have to just check which is the highest value and which is the lowest value and then choose a scale. And this scale can be written at the top right corner of the graph. So when you draw a line graph, you have to represent both the quantities using a point in between these two lines, in between the x and the y axis. And finally, you have to just join these points by smooth curve to finally get the graph. In this chapter, we will be learning about distance time graphs and velocity time graphs. You can see this graph where we have represented two quantities, distance and time. Time being an independent variable is represented in x-axis, and distance being the dependent variable is represented on y-axis. And how have we chosen the scale? So 1 centimeter, if you see the x-axis, 1 centimeter is taken as 5 seconds. And if you see the y-axis, 1 centimeter is taken as 10 meters. So according to the data given, if it is given in a tabular form, we have just represented the quantities using points. So here in this case, the object has traveled 10 meters in the first 5 seconds. Then again 20 meters when it was 10 seconds. And after every 5 seconds, it has covered a distance of 5 meters. So you have just represented these quantities using dots and then slowly joined all the dots. So when you join all the dots, you get a straight line, and this gives an example of uniform motion. You remember, when an object travels equal distances at equal intervals of time, So this graph represents an object in uniform motion. This will give you a clearer picture. You can see the dotted lines which indicates the distance traveled at particular intervals of time. So after 1 minute, the object has traveled 10 meters, 2 minutes, 20 meters, 3 minutes, 30 meters, and so on. So when you join this, you get a straight line which shows uniform motion. So the distance time graph of an object moving with uniform speed or uniform motion is a straight line. So whenever you see a distance time graph and if you see it is a straight line, then you have to infer that the object is in uniform speed. Now what if the object is moving with a non-uniform speed? So when you join the dots, you will not be getting a straight line, but you will be getting a curved line. You can see here the example where the distance time graph shows a curved line. So this represents an object which is moving with a non-uniform speed.